Let's start the next topic, that is alcohols may be monohydrate containing only one OH group. That is, monohydrate means that the alcohol has only one OH group, and then the alcohols can be dihydric, that is containing two OH group, or polyhydric, that is containing like three or more OH groups. Okay, so now in allylic alcohols, OH group is attached to sp3 hybridized. Allylic alcohols. So this goes for an allylic alcohol, that is an alcohol. It goes for an alcohol. Then in phenol, OH group is attached to sp2 hybridized carbon. This may be monohydric, dihydric, etc. The dihydric phenol further may be ortho, meta and para derivative. This is the figure for the same. This is hydroquinone. Structure of alcohol and phenol. The oxygen atom of alcohol is Hp3 hybridized, and they have tetrahedral position of hybrid atomic orbitals. The angle between them is 108.9 degree. Now the nomenclature for alcohol and phenols. In IUPAC system, alcohol are named by replacing the last word E for the corresponding alkane by ol. That is, propane. This is propane 1, 2, 3. So this is propane 1, 2, 3 triol. This is a ring, benzene ring, that is, and the alcohol is in the 2 position, that is 2 methyl. This is a phenol, that is phenol, 2 methyl phenol. And here it is a pentaquinone 4. This is a pentagon. Then so the alcohol is in 1. The methyl group is in 2 and 4. So 2,4 dimethyl phenol. This is pentanol. Then comes the preparation of alcohol. So preparation of alcohol, firstly let us study from alkenes, that is Dawes process. By acid catalyzed hydration in accordance to Markovnikov rule. This is the mechanism. And by hydroboration oxidation from carbonyl compounds, and from Grignard reagents, that is Grignard's reagent, that is RMX RMGMX. R in place of R there will be CH3 or C2H5 anything, and Mg is magnesium, and X is any haloalkyl. And also there is another process, that is hydrolysis of alkyl halides. This is very important. This is a very important reaction. This is hydrolysis of ethers, and this is the reaction from primary amines. This is also important, but this is the most important reaction. By alcoholic fermentation. This is not much important. And the next topic is preparation of phenol. From Shivi Singh Thakur asked me which book. Let me show you the book. This is the book. Very good book for students. This is 295 rupees. And always remember, NCRT is always there. NCRT is required. Okay, without further discussion, let's go to the next topic. That is preparation of phenols. This is from haloaries. This is the most easiest process, but also the most important one here. Yeah, cumin is also important. Haloarenes, this has a special condition to perform, like it requires 623 Kelvin and 300 to 480. This is the most important. And this is from benzene sulfonic acid. This is the process by oleum. This is also really important. This is a benzene. You add oleum, then it converts into benzene sulfonic acid, and then when you add any OH to it and H plus, then you get a phenol. Then the next process is from diazonium salt. This is from the process of diazonium salt. Okay, so for the diazonium, you need to take NH2, that is so much noise. NH2, then you need to add NaNO2 plus HCl. That is required for this reaction. NaNO2 plus HCl. It is HNO2. HNO2. This is HNO2. NaNO2 plus HCl. You can write HNO2 here. The sound is not clear. How to improve it? The mic is just in front of me. How to do it? When you add it when you add HNO2, you get this. This is actually the benzene diazonium chloride, and then you like give a warm water, give some warm water, you get phenol plus N2 plus HCl. You don't need to learn the side product but only know the reaction. Side product is not much important. Now the process is from cumin. Okay, so this is the very important process but very easy to learn as well. What is a cumin? Cumin is like when you attach a CH and a CH3 and a CH3 on the both sides of a CH in a benzene ring. This is so easy, and you add O2. Just remember, you need to add the O2. What is the process? You don't need to learn the mechanism. The mechanism is out of syllabus. Uh, just remember, when you add the O2, just insert the O2 in between of the C and H. This would be so easy for you. And what is this form? Cumin hydroperoxide. Then add H plus and H2O. Make a phenol out of it and write all the side products. Remember, the side product is acetone, that's why you match the formula and write it. This is very easy but very important. Let me give you a trick to learn it. Add the O2 in between of the C and H. Remember, give the O2 and add it between them. This will help you. And add a H plus and H2O. Now the preparation part is complete. Now let us go to the physical properties of alcohol. Lower alcohols are colorless liquids. I'm not reading them out, just take a screenshot. Done. Okay, so chemical reactions common to alcohols and phenols. Okay, cleavage of OH bond is common. I'm not going to show you this. This is not required much. Let's move on to the next topic. Okay, move to the next topic. No Akshat, it's not NCRT, it's a different book. It's this one. This is used for revision, complete revision. Let us start again. This is not important. Let us go to that reaction part. Okay, so let us come to the reaction part. Okay, so this is the reaction part, that is identification of alcohol. How can you differentiate 1 degree, 2 degree and 3 degree alcohol? Are distinguished by Lucas test and Victor Mayer test. So let us first see the Victor Mayer test. See, when you add like red phosphorus and iodine in 1 degree alcohol, what happens? It forms this compound, and then you need to add AgNO2, silver nitrate, and it forms this compound, and then the last step is to add HNO2, that is nitrous acid, HCl plus NaNO2. HCl plus NaNO2, that is nitrous acid, HNO2, and finally it is formed. This compound is formed. This is known as nitric acid, and this is an alkali. So what color will the 1 degree alcohol show? It will show blood red color. This is the distinction test. Blood red color. Then let us start with 2 degree. R2 CHOH. Add red phosphorus and iodine, you will get this compound, and then add AgNO2, it will become this. Then add nitrous acid, HNO2, not nitric acid, nitrous acid. It will form pseudonitrile. It's so easy to remember because the steps are same. And then it forms an alkali which is blue color. Blue color. Then the last one. The last one. I'm not waiting for anyone. The last one, how to identify the 3 degree. See, 3 degree, there is no hydrogen with the carbon, right? So this would not form the end product. This would not form the alkali. Add red phosphorus and iodine. R2Ci would form, and add silver nitrate, and then add HNO2. No reaction because there is no hydrogen to further continue the reaction. That's why it forms no reaction. Now the next thing comes, that is Lucas test. This is very important and very interesting. What do you need to add? In Lucas test, it is a test done by adding ZnCl2 and concentrated HCl, equimolecular anhydrous ZnCl2 and HCl, equimolecular HCl and anhydrous ZnCl2. It will, the primary in this one, the tertiary will show turbidity immediately. The secondary will show turbidity within 5 minutes, and the primary would show turbidity will not show turbidity. Okay, immediately within 5 minutes, no turbidity because it does not react. Now oxidation, this is not much important, that's why not explaining it. Now this is the chemical reaction for phenols. Halogenation, that is bromination. Okay, this is the bromination basically, which is written as halogenation because bromine is added. Learn this is very important. This is bromination. Add Br2 in excess. If you add Br2 in excess, what happens? It forms 1,6-tribromo-phenol. Basically, it's in an hydrous, like something is missing here. It should be H2O here in polar solvent. This is the polar solvent reaction. You need to add H2O. I don't have a pen right now. Here it should be H2O, and it forms 2,4,6-tribromo-phenol. And then when you add it into a non-polar solvent, that is CS2, it forms two products, right? One is in the ortho position, one is in the para position. And there's sulfonation, there should be one more reaction. Okay, so let me explain. You add concentrated H2SO4. When you add it in 20 degrees Celsius, this compound is formed. When you add it in 20 degrees Celsius, this compound is formed. When you add it in 100 degrees Celsius, this compound is formed. The position is different, okay, for different temperature. This is formed when you add the H2SO4 in 20 degree and this is found when you add H2SO4 in 100 degree. This is to be kept in mind. Then nitration. Nitration. What you need to add is HNO3, nitric acid plus H2SO4, both concentrated. Then you get this. This is picric acid. This is the formation of picric acid. Okay. If you add this like concentrated, picric acid will be formed. And if you add HNO3 in room temperature, then this compound is going to be formed. Remember. This is very important. This picric acid formation is very important. Then the most important reaction is Reimer-Tiemann. I am thinking of explaining it, but it is a revision series, no importance. How can I explain it right now? You guys already must be knowing it. Still, I am explaining. This is a phenol. You add chloroform CHCl3. This is chloroform, and you add aqueous NaOH. Then a compound is formed, and then you need to again add NaOH. This is better explained in NCERT. Coal-based reaction. These are the special reactions you need to learn. I'm not explaining them because these are all like very basic but very important. You need to just practice them 1,000 times. Not important very much. Physical properties, this page is not important. Now let us go to ethers. Let us go to ethers. Okay, here we go. What is a ether? This is a symmetrical ether. Okay, you have oxygen in between and you have CH3 and CH3 on both the sides, then it is a symmetrical ether. Then this is also a symmetrical ether because you have same group on the both sides. This is not a symmetrical ether because you have different groups on the both sides. This is also not a symmetrical ether. The bond angle between them is 117 degree, 0.7 degree. Nomenclature, this is very basic, you just need to learn it. Then comes the preparation. So ether's preparation is simple. This is, you need to take this in excess. This is not much important, but Williamson synthesis is way too much important. Learn it anyhow. Okay, for Williamson synthesis, only primary halides when react with sodium alkoxide give ether. Okay. Then there is physical properties and chemical reaction. This is the last part of the lecture today. I will post this on my Instagram because everybody couldn't join the live. So Chafahaknak, what is your name? I cannot pronounce it. 11 class में हो teacher. Okay, I also told Iron, this is class 12. Learn this is so important. This one is very important. This is very easy also. Just know this reaction, you will know the know all thing about this one. And this order of reactivity is very important. Good, learn all. This is the last, this is the reaction of anisole, and this is very important. Okay guys, so the class ends for today. Tomorrow I will be back again, or maybe day after tomorrow, with a new chapter, hello alkyls and hello aryls. I will explain this chapter, hello alkyls and hello aryls. It's a big chapter also. Then we will do P block, turn 1 syllabus basically. Then we'll do P block, and then eventually we'll go to that solution, and then solid state, and then at the last biomolecules. Then all the chapters will be completed and the syllabus will be done. So today we did the whole chapter of alcohol, phenols and ethers. I will post this live video in my Instagram so that you guys can see it whenever required and take the necessary screenshots. Bye guys.